Okay, so today we're going to be learning about Lewis dot structures. So what are Lewis dot structures? All that a Lewis dot structure is a quicker way to write the Bohr model in a way that will help you when we start talking about how things chemically react. So if I asked you to draw the Bohr model of oxygen, what you would come up with is something that would look kind of like this. Okay, it would have 8 protons in the center, 8 neutrons, and then we're going to have 8 electrons, 2 in the first ring, 6 in the outer ring. When we go to do chemical reactions, the only thing that participates in a chemical reaction is the electrons. So it doesn't make sense for me every time to draw everything that's in the nucleus, and it really doesn't make sense for me to draw things that are in the inner rings, because the only ring that can participate in the reaction is that outermost ring. We call those the valence electrons. Okay, the valence electrons. And they're just the electrons located in the outermost ring. So if I look at oxygen, I see that there are 6 valence electrons. We're going to indicate that in the Lewis dot structure. To do a Lewis dot structure, the first thing we do is we just write the symbol for the atom. If I look on the periodic table, oxygen's elemental symbol is just O. Okay? We're going to put around that oxygen several dots to let us know how many electrons there are. Okay? So each black dot represents 1 electron. The first electron out of our 6 we put here in the upper right-hand corner by the oxygen. So that is going to be position 1. And of course I'm trying to draw with a pencil. The second black dot would go here, position 2. The third black dot goes at the top. Where do you think the fourth one goes? Well, if you did not answer right here, you were wrong. Why? Well, we're going to see a little bit later what these shapes mean. But what you find is when you add electrons, they pair up, but they pair up in a pretty unique way. The fifth one, the sixth one, and then we'd be done. So we show that oxygen has 6 dots around it. Pair here, a pair here, and then the fourth and fifth one are unpaired. If we had to add in a 7th one, it would go right above my 4th. And if I had to add in an 8th one, it would go right next to my 5th. So let's look at another atom. Let's look at, say, a calcium atom. Calcium has 20 protons, which means it has 20 electrons. We don't care how many protons and neutrons are in the center when we do a Lewis dot. We don't care how many are in the innermost rings. All I'm looking at is that outermost ring of electrons. And if I look at that outermost ring, I see 2. So what that tells me, so I'm going to write my symbol. Calcium is Ca. We're going to add in dots for the sake of uniformity. I'll just copy and paste. Oh, got a little piece of the O. Let's try, that's too big. Nice tight little box. There we go. We only have 2, so the first one, the second one, and we're done. Calcium, 2 electrons in its valence. Let's look at another one. So what if we did instead something like element number 18, argon. If we look at argon, argon's Bohr model would look something like this. We're going to write its symbol. Argon is AR. We're going to get our dots. First dot, second dot, third dot, fourth dot, fifth dot, sixth dot, seventh, and eighth. Okay. So, hopefully by now, you've all mastered the art of drawing Lewis dot structures. What I want you to do, if you remember, we built our little atomic models. You had to fill out the 4 circles based on your element. I want you to draw the Lewis dot structure for the element that you were assigned. We've already done a couple together. So if you have oxygen, calcium, or argon, you should have no problem getting that right. If you have something else, well, you should have no problem getting that right too. Just remember, we only include the ones in the valence shell, the outermost orbital. That concludes our lesson on Lewis dot structures.